our final factoring section, that of mixed up factoring. This will require you to think on your feet and apply the appropriate method. Rob, can you bring in that board, please? Now, this is Rob's how-to of factoring. First, you've got to do common. Then you got to start counting terms, looking for difference of squares, sum and difference of cubes. If we got 3 terms, we're looking at trinomials. If we get past that, we're into grouping, buried difference of squares, and unfortunately the factor theorem. So here's our first example, and if we bring in our factoring sheet, we notice that we have to do common first. And 5 is the common factor. That's going to leave us with a trinomial, simple trinomial. Factors of minus 48 that add up to plus 2 are plus 8 and minus 6. So, boom, 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 we're going to have 5 times x plus 8, x minus 6. We have factored completely. Now, this is a hummer of an example. Bring in the factor sheet. We can think back and forth, but we're going to use the factor theorem. So let's start by substituting in x equals plus 1. We go through all the calculations and we get minus 14. That's not 0. So let's go back and substitute x equal minus 1. And a whole bunch of brackets and signs and stuff to worry about. But eventually we get minus 180. That ain't equal to 0. So let's try x equals plus 2. And we go through the same rigmarole of brackets and cubes and taking to the 4th term. But when we add it all up, it is equal to 0. So we know that one factor is going to be x minus plus 2. And of course, we would write that as simply x minus 2. Now we need to perform that whole expression divided by x minus 2. Well, there's no easy way around it, and whatever. We're setting up a long division. And, as always, careful. Watch out for subtraction. But it does work out to a nice number. So far we have this long expression equal to x minus 2 times another long expression. Now we need to work on that 4-term polynomial, and we can hum and haw, but we're going back to factor theorem. We've already tried plus 1 minus 1, so let's try plus 2 again. And it's not quite as long, not quite as complicated, but thankfully we do get 0. So we need to take that 4-term polynomial and divide by the factor that we're going to get, which once again will be x minus plus 2, or x minus 2. So now we need to perform the division. It ain't pretty, but as we go along, being very careful of subtraction and lining up terms the correct place, it does work. So there are 2 factors of x minus 2. Now what it leaves us with is a simple trinomial, x squared plus 3x minus 18. And a little bit of thought tells us plus 6 times minus 3 is minus 18. Plus 6 plus minus 3 is plus 3. So, our huge, enormous term is going to break down to 4 brackets. 2x minus 2's and an x plus 6 and an x minus 3. So that example be done. Let's move on to another one. All right, we're going to get a lot of squares here. So we bring in our factor sheet. Now, there's nothing common, and buried difference of squares is tempting, but we're going to go to grouping. And grouping will yield success for us, basically. And as we calmly do it, we get a common bracket of 16y squared minus 25, which is a difference of squared, and 4x minus 9, which is also a difference of squares. And so we can take that, and suddenly we will get 4 brackets. 4y plus 5, 4y minus 5, 2x plus 3, 2x minus 3. And that one be done. All right, our final example. This is one that you don't want to face. You can look at the coefficients. You can see 4, 16, and 7 are in there. So we're going to change the order to get in that order of 4, 16, 7. And that's going to allow us to group the expression. And once we group it, we can see that we have a trinomial and a difference of cubes. So working on the trinomial, we're working for plus 28. Minus 14 times minus 2 is plus 28. Minus 14 plus minus 2 is minus 16. So we can group the first one. The second one is a difference of cubes. That's a straightforward operation. And once again, we finish with 4 brackets.